So the goal of this video is a series of videos is to show you what lenses do to light. So plus lenses converge, parallel light converge. That's a plus lens, and plus lenses are fat in the middle. Minus lenses are skinny in the middle, and they diverge parallel light. And so I have, just move the camera, I have a plus 12 lens here. And you can see when I get it to about 8 centimeters away from the wall, the light is in nice crisp focus. If I go closer or further, it's a circle, but it's not in focus. So at the focal distance of this plus 12 lens, it's about 8 centimeters, the parallel light comes in and converges to a nice point. This is a plus 5 lens. It does the same thing, but its focal distance is a little further away. It's about 20 centimeters away from the wall. If I go too close, it's blurry. If I go too far, it's blurry, but a nice point. Now the minus lenses diverge the light. So this is a minus 4, and you can see the light makes a halo around the lens, because as the parallel light comes in and hits that lens, it's diverged away from the center of the lens, and it just can't get in focus anywhere. It just spreads out and it makes that nice little halo. And same thing for a minus 20 lens, just the same halo, kind of pretty there. You just can never get this to a nice focus. You get that little spray of light, that halo of light, but that's not a focused image. And these are, I don't know if you can see this, spherical lenses, fat in the middle, round. Now, the toric lenses, correct for astigmatism, and they are, if you can see this, this is a cylindrical lens. It is flat in this meridian, but curved in this meridian. And so it brings light to a focus, if you can see that, parallel to the axis, a nice focal line. And this axis, if you imagine this with tires spinning on either end, this would be the axis that holds those tires together. No curvature lengthwise, no power. All the power is 90 degrees away because it takes curvature to refract. It takes curvature to make power. If we grab our lenses, these are plano in one meridian and have power in the other. This is a plus 6 sill. You can see how it makes a nice parallel line of light at its focal distance. This is a plus 6 sill, so it's about, I don't know, 16 centimeters away from the wall. It makes, you can't see it probably, but there's little tick marks here showing me the axis of this lens is horizontal, which is 180, axis 180. We never call it 0, it's always 180. And if I hold it at the right distance, I get a nice crisp line where the light converges just in that one meridian. Go too far, it's blurry. Go too far this way, it's blurry, but right at the right spot, nice focal line, parallel to the axis. Now this is a minus sill lens, and you can see the little tick marks showing the axis at 180. If I go close, far, it doesn't really matter. I can never get this lens in focus, but you can see how it spreads the light parallel to the axis in the vertical meridian. Now that sounds kind of funny to say, but here you can see all the action is the vertical meridian of the lens bringing, with the plus lens, bringing the light to a focal point parallel to the axis. Same in the minus lens, all the action is in the vertical meridian. The horizontal is the axis. And you can see the width of these light beams is the same horizontally. So this one and this one, the light that you see is the width of the lens in each case, because there's no refraction in the horizontal meridian. All of the refraction is in the vertical meridian. The plus lens converges, the minus lens diverges. And it's always confusing and annoying. But if you can see this, the curvature here is what causes the convergence. The straight meridian is the axis, and it has no converging power. The light just passes straight through.